So in this example, we want to fit a sinusoidal model of the form y equals a times sine of 3x plus b to given data. And the data is going to be given to you in a map file. So these are Matlab's data files. So the first step you'll need to do is to load that file into Matlab. Now, before we get involved with Matlab, I think it's really good to sit down with pencil and paper and figure out what some of the equations might look like so that we can then try to understand what our matrix would look like. If we just try to do this all in Matlab, it becomes a little bit more challenging. So I recommend just writing down a sample equation so we get a feel for what this is going to look like. So let's just pretend that we had a data point, x, y here. You could call it maybe 3, 7, just to play, just to get a sense of how the model's going to look. I know we don't really have a 3, 7, but let's just pretend, okay? So if that were the case, then we would have an equation that looks like a times sine of 3 times 3. Let me make this an 8 so it's a little bit different than the 3 that was in our model. 3 times 8 plus b, and that would give us some output value of 7. So notice that this is where our x is going to sit, and this is where our y data is going to sit. So when we come over here and we start to look at how the matrix would appear, keeping in mind that our first column we will have coefficients for variable a, second column will be our coefficients for variable b. So the coefficients that sit on variable a look like this whole piece, sine of 3 times x, or 3 times 8. So for the first row there, that would have been a sine times 3 times 8, and our second column here would just be 1 times b, and then we'll have many more equations, etc., as we go. Vector v will be our a and b coefficients that work in our model, and then we'll have a big column vector for y, whatever is given to us in this data file. All right, so our setup will look like, let me make a little space right here. Matrix A will have a first column that looks like sine of 3 times x, and that'll be our entire first column. We'll have another column that's a bunch of 1s. That'll be a big column, so we'll have 2 big columns there. Then we have vector AB, and lastly, that all equals y. So let's head over to Matlab to see how this is going to pan out. So I've loaded the data file, and as any good data science, you should try to peek at your data before you try manipulating it. So let's see what's in here. Now we've got an x, a capital X, and a capital Y, and those are 629 rows long, one column. All right, let's try to do a scatter plot. Okay, there's the scatter plot. We can kind of see a sinusoidal model emerging here, so that makes sense to why we would be doing a sinusoidal model. And let's set up A. A is going to be a bunch of zeros, and we know it's 629 rows long. We know we're going to have 2 columns. Now, for the first column of A, we said that that is going to be sine of 3 times vector x. And we meant capital X. There we go. The second column of A is going to have a bunch of 1s, and that was 629 rows long. And again, I've intentionally left off the semicolon there so we can just kind of peek to what A looks like. It's a pretty big matrix. Y is just Y, so we're now ready to say V equals P inverse of A times vector Y. So there's our A and our B value. Okay, we have a scatter plot. Let's hold on to that scatter plot. Let's set our mesh grid. Now let's go up to 7 or so because our data extends a little bit farther in the X direction. Let's plot. So we're going to plot our mesh points, and what we're going to do is we're going to plot our mesh points A times sine of 3 times X mesh points plus B. And we have a beautiful plot in here. It's a little bit hard to see our line, and so you should definitely go in here and make that line a little bit bolder. And so if we click on that line, we could make this maybe red would be a nice touch, and we could certainly make it nice and thick. That looks beautiful.